Hi everybody. So I thought I would make another video about factoring for you. Thought this might be helpful. Factoring by grouping is what I'm talking about here. It's kind of a tricky topic sometimes. It takes some getting used to, so I thought maybe having the chance to hear it again and pause and whatnot would be helpful. I want to start off by saying that the first thing you want to do for any equation or expression you're factoring is look for a greatest common factor for the entire expression or equation. Look for a greatest common factor for everything. This method is going to use kind of partial greatest common factors or half greatest common factors, and that's not to be confused with the greatest common factor that you should try and find for every single thing you always factor. All right, so factoring by grouping is something that you use for polynomials that have an even number of terms. Here in the write-up I say 4 terms. You could also do this for 6 or for 8, but there are 1, 2, 3, 4 terms here. There have to be an even number. So what you're going to do is you're going to look at the first 2 terms, x cubed and negative 2x squared, and you're going to try and find a greatest common factor for them. So the greatest common factor for those two is x squared. And the leftovers are x minus 2. See if you can look at the next 2 terms and find their greatest common factor. The greatest common factor for the next 2 terms, or the last 2 terms, is going to be 9. So 9 times x minus 2. We can't just write it like this. It shouldn't be multiplication. Does it make sense that since there's a plus sign here, it should be addition in between? So this method of factoring is going to work out whenever you can make the leftovers the same thing. I promise it's not magic. Take a look at it. X squared plus 9 times x minus 2 is how this factors. So the most common questions are, why is there just one x minus 2 when there are 2 in the step above? I'm going to highlight this other part in green just so you can, to make sure you know where the x squared plus 9 is coming from. So I kind of want to think about this in the reverse to see if we can figure out where this comes from. If I was going to distribute this final step to check my work to make sure I got the initial step, I would multiply x squared by x and by negative 2. In the step above that, can you see that I'm multiplying x squared by x and by negative 2? And then I would multiply 9 by x and by negative 2. And I'm doing that same thing here. As with any factoring problem, we're going to look at our final answer, and we're going to ask ourselves, could this go any further? X minus 2 doesn't factor. That's as simple as possible. That's called a prime polynomial because it doesn't factor. And x squared plus 9 I know is tempting because we've talked about differences of squares and sums of cubes, but this doesn't factor. If it's x squared, it would have to be minus 9. So here is another problem that is very similar. Pause the video for a second and see if you can figure out the similarities and differences. If you want to try and work out the first few steps, you can. Okay, hope you had time to pause. This would factor to x squared times x minus 2. Now this method of factoring is only going to work if you can turn these last 2 terms into x minus 2. In order to do that, what number are you going to have to put in front? It's actually going to have to be negative 9. In order to make negative 9x and positive 18, you'd have to use negative 9. So kind of thinking about what we did on the previous slide, that would factor down to x squared minus 9 times x minus 2. Again, we're taking those 2 terms and we are combining them. We're actually reversing the distributive property. Now, this isn't a final answer because this now is a difference of squares. So our final answer for this problem would be x plus 3 times x minus 3 times x minus 2. So I've got two more problems for you that I want you to pause the video and try, and then I will put the answers up in just a second. So go ahead and pause the video, give these a try, and I'm going to put the answers up. All right, so here are the answers. The first problem here on the left is very, very similar to the one that we started with. You still have a difference of squares, just like the last problem, which I'm going to factor down to x plus 4 and x minus 4. If you understood what was going on in the last slide, this one should be pretty straightforward. The one on the left, however, or the one on the right rather, is a little bit different because it's not going to factor down to a quadratic term. It's going to factor down to a cubic. I have x cubed minus 8. These two, they don't have a number in common because 5 and 4 are relatively prime, but they do have x cubed in common. So when we take out the x cubed, we're left with 5x minus 4. We need to ask ourselves, can we turn this section into 5x minus 4? Yes, if you take out positive 8. Positive 8. So in this red and now purple step, that is going to factor because it's a sum of cubes. A sum of squares, we just said on 2 slides ago, doesn't factor, but a sum of cubes does. So we're actually going to get x plus 2 times x squared minus 2x plus 4 times 5x minus 4. If you're having trouble getting from here to here, you may want to ask me about that. All right, thanks for watching.